Hello everyone. In this video, I'm going to discuss integration by partial fractions. Sometimes if you have a rational function which is hard to integrate, you can express that as sum of simpler fractions which are easier to integrate. And for this, we use our partial fractions decomposition which I discussed in the previous two videos. So in this case, our first step would be to break this rational function into partial fractions. Thus, we're going to write 2 over x minus 1 times x squared plus 1 as sum of some fractions. And how we're going to decide on what should be the denominator? So first we have a linear factor. So that would be our denominator. And then we have a quadratic expression which would be our another denominator. So I just want to make sure you don't mix two things up. So if you have something like 2 over x minus 1, x plus 1 whole square. So in this case, you have only two linear factors and then degree of a linear factor. In that case, your partial fraction would have been, so denominator this, and then you have x plus 1 power, and then c over x plus 1 whole square. So then you get three terms. But in this case, because this is our quadratic expression of the form ax squared plus bx plus c, so we only get two terms. So don't mix these two together. And on the top of linear, you're going to have just a simple constant. And on top of quadratic expression, you're going to have something of the form bx plus c. And then we're gonna try to find the value of constants a, b, c. Thus multiplying both sides by x minus 1 x squared plus 1, we get 2 is equal to a times x squared plus 1 plus bx plus c times x minus 1. And then we do the expansion of the terms. On this side we get ax squared plus a plus bx squared minus bx plus cx minus c. And let's just do a little bit of rearrangement of the terms. So x squared terms together, so we combine them, so we get a plus b. And similarly for x terms, we get negative b plus c, and for the constant terms we get a minus c. And now is the time to equate the like terms on both sides. First we're going to equate the terms of x squared. So on this side we have 0. So it means a plus b equals to 0. Then we're going to equate the coefficient of x on both sides. So we're going to get negative b plus c equals to 0. And equating constant term, we get a minus c equals to 2. So we have three equations, three variable, and we can solve them to find a, b, c. So solving these, how we gonna solve this? From here we get b equal to c, and we can put that value here. So we get a minus c equals to 2 and a plus c equals to 0, and then when you add those terms together you get value of a. So 2a is equal to 2, so a is equal to 1, or you can simply use your calculator. So a equals to 1, b equals to negative 1, and c equals to negative 1. Thus, putting the values of a, b, and c in this equation here, we can write integral of 2 over x minus 1 times x squared plus 1 dx can be written as integral of 1 over x minus 1 dx minus integral of x plus 1 over x squared plus 1 dx. So I have simply put the values of a, and here we have bx plus c, and negative is taken out. And in the next step, we're going to solve these integrals. So how to solve integral of x minus 1 over x minus 1? So that would be ln mod x minus 1. And for this one, we can decompose this again. We can rewrite this as into two integrals. So x over x squared plus 1 dx and minus integral dx over x squared plus 1. So ln of mod x minus 1, and here you can think of this as your logarithmic form because you have a function, so 1 over fx, and then you can make the differential of the function on the top for f prime max dx. So in this case, that is ln of fx plus c. So in this case, we just need a 2 to make the differential of x squared plus 1. So we get half ln of mod x squared plus 1. And then the last one is again, so you have this form in, so that's inverse tan form because integral of x squared plus a square, so 1 over x squared plus a square, so that is tangent inverse x over a 1 over a. So we have this inverse tangent form. So this should be equal to tangent inverse x plus c. So that is our required integral of 2 over x minus 1 x squared plus 1 dx. Thus, integration by partial fractions is used when you have a little bit complicated rational function, and you can write that as simpler fractions, sum of simpler fractions, and then easily integrate those fractions. I hope you enjoyed this video. So thanks for watching. See you next time.